Today, I will introduce our paper titled VS, Reconstructing Clothed 3D Human from Single Image via Vertex Shift. This is an article about clothed 3D human reconstruction. Recently, methods like PIFUHD that are based on implicit functions have made progress in reconstructing humans with diverse clothing and poses, but they often produce severe distortions. Subsequent methods such as Pamir and Icon use parametric models like SMPL and SMPLX to regulate these functions, reducing distortions in complex poses but limiting flexibility in loose clothing. Although Econ has improved the quality of reconstructions, it still faces some issues. We propose a two-stage reconstruction method called VS to address these two aspects mentioned above. It uses a stretch-refine strategy to reconcile the contradiction between large deformations required for reconstructing loose clothing and delicate deformations for recovering details. Stretch VS transforms the estimated SMPLX mesh into a coarse 3D human model using displacement fields inferred from normal maps. In our method, the displacement fields are inferred by establishing the pixel-wise correspondences between the body normal maps and the clothing normal maps. Stretch VS shifts vertices on XY planes while maintaining the depth of SMPLX, since it is challenging to estimate high-precision depth from 2D images using concise algorithms. Vertex shifts in the Z direction will be handled by the Refine VS module later. Refine VS refines the coarse 3D human model into a detailed 3D human model via a graph convolutional network embedded with implicit function-learned features. This is the result after Refine VS. This is the final result. Figure shows the reconstructions by applying our VS on in-the-wild images. Figure demonstrates visual comparisons with all 5 SOTA methods on in-the-wild images. Figure shows the reconstructions by Econ and our VS. It can be seen that VS recovers high-fidelity 3D humans while Econ struggles with missing parts, incomplete loose clothing, wrong thickness, and incorrect poses. As illustrated in table, VS demonstrates superior performance on all 3 benchmark datasets. Especially, our VS exceeds all other methods by a large margin on the 2 metrics that represent large geometric errors. Next, we will show more results. To assess the effectiveness of the Stretch VS and Refine VS modules in VS, we implemented 2 variants of VS, each exclusively incorporating either the Stretch VS module or the Refine VS module. It is evident from these results that one Stretch VS exhibits a significant performance decrease on all 3 datasets, especially in terms of local details. 2 Refine VS performs consistently on Thuman 2.0 and Cape without significant degradation, while it exhibits a noticeable decline on Render People. In order to verify the robustness of the method, we use both accurate and inaccurate SMPLX estimates to initiate VS. As shown in figure, VS can achieve high-quality reconstructions even with inaccurate SMPLX estimates. Since Stretch VS treats SMPLX just as a seed and stretches it to align with visual cues, it has the error-correcting ability to shift vertices on inaccurate SMPLX estimates to proper positions. Here is a detailed introduction to our paper. We welcome everyone to join the discussion.